The explosion was so huge that it lifted the entire German bunker off its foundation, throwing chunks of concrete the size of cars 50 yards across the land. Canadian engineers crouched in their trench, covering their heads as debris fell all around them. When the dust finally settled, the German position was gone, leaving only a smoking hole and silence. The lieutenant in charge of the engineers stared at the damage, then looked at the strange device his men had just set off. 12 PIAT anti-tank weapons were wired together in a circle, their warheads pointing toward a central detonator. It looked like something a kid might make in his backyard, not a real weapon, but it had just destroyed a reinforced concrete bunker that had held up an entire battalion for 2 days. This wasn't in any manual. The PIAT, Projector Infantry Anti-Tank, was supposed to shoot one warhead at a German tank from about 100 yards away. It was a terrible weapon by most accounts, heavy, awkward, and often misfired. Soldiers complained about it constantly, using it only because there was nothing better. But Canadian engineers in Normandy discovered something the designers hadn't planned for. If you took the warheads off several PIATs, arranged them in a special way, and detonated them all at once, you could create an explosion strong enough to destroy fortifications that regular explosives couldn't. It was a desperate move. But by the summer of 1944, it had become one of the Canadian Army's best tools for breaking through German defenses. The whole thing started with how much soldiers hated the PIAT. Introduced in 1943 as Britain's answer to German tanks, the PIAT was disliked by almost everyone who had to use it. It weighed 32 pounds, had a cocking mechanism that needed the strength of 2 men, and kicked like a mule when fired. It was meant to shoot at tanks from about 100 yards, but most soldiers didn't trust it past 50 yards. It misfired often, and when it worked, the warhead was just as likely to bounce off a tank's armor than go through it. But there was one advantage. Unlike a bazooka or Panzers, the PIAT didn't use a propellant charge. It worked on a spring mechanism, meaning it didn't create smoke or flames that would give away the shooter's position. You could fire it from inside a building or a bunker without blowing yourself up. It was useful for urban combat, but soldiers still hated it. Canadian soldiers got PIATs in late 1943 as they prepared for the invasion of France. Training with them was tough. To cock the weapon, you had to lie it on the ground, put both feet on the shoulder rest, and use your whole body weight to pull up on the barrel. Even strong soldiers struggled with it, and smaller men often couldn't cock it without help. Once it was cocked, you had to carefully load the warhead, aim the awkward weapon, and pull the trigger before the spring mechanism failed or your arms gave out from holding it steady. The weapon's effective range was supposed to be 115 yards, but hitting anything beyond 50 yards took more luck than skill. The sights were hard to use, the flight path of the warhead was unpredictable, and the spring tension varied depending on the temperature and how much the weapon had been used. Even with all these problems, the Canadian Army gave the PIAT to infantry units because there was no better option. The American bazooka was in short supply and mostly went to American units, while British anti-tank guns were too heavy for infantry. The PIAT was portable, at least, and it could, in theory, stop a tank if everything went right. So the Canadian soldiers carried them when they landed in Normandy on June 6, 1944, knowing it was a poor weapon but having no better choice. The invasion of Normandy quickly showed the PIAT's weaknesses. Canadian infantry came up against German tanks that the PIAT couldn't penetrate. Soldiers reported firing at tanks from dangerously close distances, watching their warheads bounce off or fail to explode, then getting killed before they could reload. The PIAT worked sometimes, especially against lighter vehicles or when hitting vulnerable spots, but it wasn't the reliable anti-tank weapon soldiers needed. But Canadian engineers were figuring something out about the PIAT warheads. Even though they didn't always penetrate tank armor, they created a big explosion when they hit a solid surface. The warheads had about 2 pounds of high explosives inside that created a big blast. Engineers had already started using them as improvised demolition charges, removing them from the PIAT and placing them against obstacles like barbed wire or bunker doors. The warheads worked decently for this, though 2 pounds of explosive wasn't enough to destroy heavy German fortifications. You needed more than one warhead to breach strong defenses, and you had to carefully place each one to focus the blast. The breakthrough came in mid-June, near Caen, where Canadian forces were fighting through dense hedgerows and facing tough German resistance. A company from the Regina Rifle Regiment had been stuck for 6 hours by a German bunker that controlled the approach to a small village. Artillery had crumbled the ground around the bunker but hadn't damaged the concrete itself. Infantry assaults had been stopped by machine gun fire. The company couldn't move forward or back without leaving their wounded behind. A sergeant named William Morrison from the regiment's pioneer platoon, who was also a construction foreman back in civilian life, was studying the bunker through binoculars. He had been watching the bunker for 2 hours, trying to figure out how to destroy something that artillery couldn't touch. The company had 3 PIATs, mostly useless since the bunker wasn't a tank and shooting individual warheads at reinforced concrete would accomplish nothing. But Morrison knew that 3 warheads meant 6 pounds of high explosive, and if you could detonate all 3 simultaneously with the shaped charges focused properly, you might generate enough blast force to crack even reinforced concrete. The problem was how to arrange multiple warheads so they detonated together at exactly the right moment. PIAT warheads were designed to explode on impact, triggered by a spring-loaded striker that hit a detonator when the warhead struck a target. You couldn't just stack them together because there was no way to ensure simultaneous detonation, and if they went off sequentially, the first explosion would just scatter the others without multiplying the blast effect. Morrison talked it through with his corporal, a kid from Winnipeg named James Chen, who'd studied engineering at the University of Manitoba before the war. Chen suggested they could wire the warheads together electrically if they could access the detonators and rig them to a central firing circuit. Morrison said they didn't have the equipment or time for electrical detonation. They needed something simpler and more reliable. They settled on a mechanical solution. Take the warheads off the PIAT projectiles, remove the impact detonators, and replace them with blasting caps wired to a central detonator that could be triggered remotely with a standard engineer's detonation device. Arrange the warheads in a tight circle with the shaped charges pointing inward and slightly upward, so the focused blast jets would converge on a single point. The combined force of 3 shaped charges detonating simultaneously in a converging pattern would create an explosion far more powerful than 3 separate detonations. Morrison had no idea if it would work. The theory seemed sound, based on what he knew about demolitions, but he'd never heard of anyone trying to combine multiple shaped charges like this. Still, the alternative was watching more men die trying to assault an impregnable bunker, so he decided to try it. Getting the warheads was easy. The company had 3 PIATs and nobody wanted to use them against the bunker anyway. Morrison's pioneers unscrewed the warheads from their projectiles and carefully extracted the impact detonators. Each warhead had a copper cone that focused the explosive force into a penetrating jet, and Morrison positioned them in a triangle formation with the cones pointing inward at a central blasting cap that would trigger all 3 simultaneously. The whole assembly was held together with communications wire, wooden stakes driven into the ground, and an absurd amount of confidence that the improvised contraption wouldn't kill everyone nearby when they tested it. Morrison positioned the assembly about 20 yards from the bunker, closer than he would have liked but necessary to ensure the blast force reached the target. He ran the detonation wire back to a crater 80 yards away, connected it to a standard plunger detonator, and told everyone to get their heads down. The explosion wasn't as dramatic as Morrison had hoped. 3 warheads didn't produce enough force to destroy the bunker, but it did crack the concrete around the firing port and stun the Germans inside badly enough that they stopped shooting for several minutes. Infantry used that window to close the distance and toss grenades through the damaged firing port, finally silencing the position that had held them up all day. Morrison's experiment had worked, sort of. 3 warheads weren't enough, but the principle was proven. Multiple shaped charges detonating simultaneously in a converging pattern produced significantly more destruction than separate explosions. If 3 warheads could crack reinforced concrete, what could 6 do? Or 10? Or 12? Word of Morrison's bunker-busting technique spread through the Canadian engineer companies within days. The idea was simple enough that any engineer with basic demolitions training could replicate it, and the materials were readily available. Since every infantry company had PIATs, they were happy to donate to any purpose other than shooting at tanks. By late June, multiple Canadian units were using modified versions of Morrison's technique against German fortifications. The engineers experimented with different configurations. Some tried linear arrangements with warheads placed in a row along a bunker wall. Others used circular patterns with 6 or 8 warheads arranged around a central detonator. The most effective design turned out to be the circular arrangement with warheads angled slightly inward, creating a converging blast pattern that focused enormous force on a single point. The number of warheads varied based on the target, but 12 became the standard for heavily reinforced bunkers because it provided enough explosive force to crack almost any defensive position Canadian forces encountered. The assembly process became somewhat standardized through practice. Engineers would gather the required number of PIATs, remove the warheads, extract the impact detonators, and replace them with blasting caps. The warheads would be arranged in a circle, typically about 4 feet in diameter for a 12-warhead assembly, held in place with wooden stakes, communications wire, sandbags, or whatever materials were available. The key was ensuring all warheads remained properly positioned with their shaped charges angled correctly, because even one misaligned warhead could reduce the overall effectiveness. The central detonator was usually a standard blasting cap connected to all 12 warheads via a spiderweb of detonation cord or electrical wire. Engineers preferred electrical detonation when possible because it was more reliable, but detonation cord worked fine if wired correctly. The entire assembly was then positioned as close to the target as possible, usually under cover of darkness or smoke, and detonated remotely using a plunger-style firing device or electrical detonator. The results were spectacular. A 12-warhead PIAT assembly carried roughly 24 pounds of high explosive configured as converging shaped charges. When detonated simultaneously, the combined blast produced a focused shock wave, powerful enough to demolish reinforced concrete bunkers, blow gaps in fortified walls, or create craters that could swallow vehicles. The explosion was terrifying to witness, a massive blast that produced a characteristic mushroom cloud and threw debris hundreds of yards. German forces had no equivalent weapon. Their engineers used conventional explosives for demolitions, and while they had shaped charge weapons for anti-tank purposes, nobody had thought to combine multiple shaped charges into a single devastating explosive device. The first few times Canadian engineers used the 12-warhead assemblies, German defenders were completely shocked by the destructive power. Bunkers that had survived artillery bombardments simply disintegrated. Fortified positions that would have required days of fighting to overcome were eliminated in single massive explosions. The psychological impact was significant. German soldiers knew that if Canadian engineers appeared with their bizarre circular explosive assemblies, their bunker was about to cease to exist. Some Germans abandoned positions as soon as they saw engineers approaching with loads of PIAT warheads. Others tried to shoot the engineers before they could set up the assemblies, leading to vicious close-range firefights around fortified positions. Canadian infantry loved the technique because it meant they didn't have to assault bunkers frontally anymore. If a German position was holding up in advance, engineers would move up, assemble their PIAT circle, detonate it, and the position would be destroyed. Infantry could then move forward without taking the horrific casualties that frontal bunker assaults normally produced. The technique saved countless Canadian lives during the Normandy campaign and the subsequent fighting across France. The danger, of course, was in setting up the assemblies under fire. Engineers had to approach German positions closely enough to place their warheads effectively, which meant working within range of enemy machine guns and rifles. The assembly process took at least 15 to 20 minutes even for experienced teams, during which they were vulnerable to enemy fire. German defenders quickly learned to watch for Canadian engineers carrying PIAT warheads and to concentrate fire on them before they could complete their assemblies. Engineers developed tactics to protect themselves during assembly. Infantry would provide covering fire to suppress German positions while engineers worked. Smoke grenades would obscure the assembly area. Diversionary attacks would draw German attention away from where engineers were actually setting up. The work was still incredibly dangerous, and engineer casualties were heavy, but the technique was effective enough that commanders kept ordering its use despite the risks. One particularly dramatic use of the 12-warhead assembly occurred in early July during the assault on a fortified German position near Carpiquet. A company from the North Nova Scotia Highlanders had been tasked with capturing a German strongpoint that anchored an entire defensive line. The position consisted of multiple interconnected bunkers built into the remains of a stone farm complex with interlocking fields of fire that made approach nearly impossible. Artillery had pounded the position for hours without effect, and 2 infantry assaults had been driven back with heavy casualties. A pioneer section from the Highlanders, led by a sergeant named Donald MacLeod from Cape Breton, volunteered to destroy the main bunker using a PIAT assembly. MacLeod had used the technique before and was confident he could get close enough to place the charges if infantry could provide adequate covering fire. The plan was executed at dawn. Infantry launched a diversionary assault from the east, while MacLeod's pioneers approached from the west through a sunken road that provided some cover from German fire. They carried components for 2 12-warhead assemblies, planning to use one against the main bunker and the second against a supporting position if time allowed. German defenders spotted the engineers despite the covering fire and the dawn darkness. Machine gun fire raked the sunken road, killing one pioneer and wounding another. McLeod and the remaining 3 men pressed forward, dragging their PIAT warheads, determined to complete the mission despite taking fire. They reached a shell crater about 30 yards from the main bunker and began assembling the warheads under continuous fire. Bullets cracked overhead and ricocheted off the crater walls while the pioneers worked with shaking hands to position the warheads, insert the blasting caps, and connect the detonation wire. It took them nearly 25 minutes, far longer than planned, and by the time they finished, 2 more pioneers had been wounded. McLeod ran the detonation wire back to the sunken road, taking cover behind a destroyed wall. He connected the wire to the detonator, said a quick prayer, and pushed the plunger. The explosion was massive even by the standards of previous PIAT assemblies. The 12 warheads detonated with perfect synchronization, the converging shaped charges focusing their blast into a single devastating shock wave. The German bunker, which had been built from 2-foot-thick reinforced concrete and had survived hours of artillery bombardment, simply exploded. The walls blew outward in chunks, the roof collapsed, and anyone inside was killed instantly by the blast overpressure. The supporting German positions, seeing what had just happened to their main strongpoint, immediately surrendered. The entire defensive line collapsed within an hour. McLeod's assault on the bunker, which had cost 4 pioneers killed or wounded, had broken a position that might have held up the entire brigade for days. McLeod received the military medal for the action, though he later said the real heroes were the pioneers who'd stayed with him in the crater, assembling the warheads while under fire. The citation mentioned his courage and determination, but didn't specifically describe the PIAT assembly technique, which remained something of an unofficial modification that commanders preferred not to highlight in official records. By August of 1944, the multi-warhead PIAT assembly had become standard practice among Canadian engineer units fighting in France. Different configurations were developed for different targets: 8 warhead assemblies for lighter fortifications, 12 warhead assemblies for reinforced bunkers, 16 warhead assemblies for especially difficult targets like concrete pillboxes or fortified buildings. Some engineers experimented with even larger assemblies, though beyond 16 warheads the assemblies became unwieldy and difficult to position properly. The technique's effectiveness depended heavily on proper assembly and positioning. All warheads had to detonate simultaneously, which required careful wiring and reliable detonators. The shaped charges had to be angled correctly to create the converging blast pattern. The assembly had to be close enough to the target for the blast to be effective, usually within 20 to 30 yards for maximum effect. Any mistakes in assembly or positioning could result in a less effective explosion, or worse, a partial detonation that scattered unexploded warheads around the battlefield. Engineers developed a healthy respect for the danger involved. 24 pounds of high explosive was enough to kill anyone within a considerable radius if something went wrong during assembly. Handling impact-sensitive PIAT warheads, removing their detonators, inserting blasting caps, and wiring everything together required steady hands and careful attention to procedure. Pioneers who got careless or rushed the process sometimes died in accidental detonations that also killed everyone nearby. Despite the risks, the technique continued to be used because it solved a critical tactical problem. German defensive positions in Normandy were often too strong for conventional infantry assault, but too dispersed or too well protected for artillery to destroy efficiently. The multi-warhead PIAT assembly gave Canadian forces a way to eliminate these positions without suffering prohibitive casualties. It was dangerous for the engineers who assembled and placed the charges, but it was far less dangerous than sending infantry forward in frontal assaults against intact bunkers. British and American forces heard about the Canadian technique, and some units attempted to replicate it with varying degrees of success. British engineers had PIATs and the theoretical knowledge to build similar assemblies, though the technique never became as widespread in British units as it was among Canadians. American forces generally preferred to use their more plentiful artillery and air support rather than improvised explosive assemblies, though some American engineer units did experiment with the concept using captured German Panzerfausts arranged in similar patterns. The German response to the multi-warhead assemblies was primarily to try to kill the engineers before they could complete their setups. German defenders learned to watch for groups of soldiers carrying multiple cylindrical objects and to concentrate fire on them immediately. Some German positions placed obstacles and barriers at specific distances from their bunkers to prevent engineers from getting close enough to place assemblies effectively. In a few cases, German units captured partially assembled PIAT rings and tried to reverse engineer the technique, though there's no evidence they ever successfully adopted it themselves. As Canadian Forces advanced across France into Belgium and the Netherlands during the fall of 1944. The multi-warhead PIAT assembly remained a standard tool for breaching fortifications. The Scheldt campaign, which involved fighting through heavily fortified German positions in flooded terrain, saw extensive use of the technique. The urban fighting in places like Antwerp and Eindhoven provided numerous opportunities to use PIAT assemblies against fortified buildings that conventional weapons couldn't effectively engage. One limitation that became apparent during prolonged campaigns was the supply of PIAT warheads. Infantry companies only had so many PIATs, and if engineers kept requisitioning the warheads for demolition use, infantry would be left without any anti-tank capability. Supply officers had to balance the competing demands, sometimes restricting how many warheads engineers could use for assemblies to ensure infantry retained some PIATs for their intended anti-armor role. This supply tension led to some creative solutions. Engineers would scavenge PIAT warheads from damaged weapons or from units that were out of the line. They'd trade other supplies to acquire warheads from infantry companies that had effective anti-tank guns and didn't need their PIATs. In some cases, engineers would use captured German-shaped charge weapons in their assemblies alongside PIAT warheads, creating hybrid explosive devices that combined Allied and German munitions in the same assembly. The technique evolved throughout the campaign. Engineers discovered that adding conventional explosives like TNT or Composition B to the center of a PIAT assembly increased the overall blast without requiring additional warheads. Some units experimented with shaped charge orientations, angling some warheads downward to create cratering effects, while others angled upward for maximum structural damage. A few innovative engineers tried sequential detonations, setting up two assemblies to explode milliseconds apart to create a hammer and anvil effect against especially tough targets. By the spring of 1945, as Canadian forces pushed into Germany itself, the multi-warhead PIAT assembly had become an established part of the tactical playbook. New engineer replacements were trained in assembly techniques by veterans who'd been building and detonating the devices for months. The technique appeared in informal training documents and unit standard operating procedures, though it was never officially adopted into formal Army doctrine. The reason for this official reluctance to embrace the technique was partly institutional conservatism and partly legitimate concern about safety and standardization. The PIAT was designed as an anti-tank weapon, and using its warheads for improvised demolitions represented an off-label use that military bureaucracies were uncomfortable endorsing officially. There were also legitimate safety concerns about training large numbers of soldiers to disassemble PIAT warheads and wire them into explosive assemblies, given the potential for accidents. But field commanders didn't care about institutional hesitations. They cared about taking objectives with minimum casualties, and the multi-warhead PIAT assembly accomplished that goal. So the technique continued to be used regardless of whether it appeared in official manuals, passed down from experienced pioneers to new engineers through practical demonstration and word of mouth. The war in Europe ended in May of 1945, and with it, the combat use of the multi-warhead PIAT assembly. Post-war, the technique was documented in after-action reports and historical studies of Canadian combat engineering during the campaign. Military analysts examined the physics of the converging shaped charges and confirmed that the technique did indeed produce significantly more destructive power than separate detonations would have achieved. Modern explosive breaching techniques used by military and police special operations units employ similar principles, using multiple shaped charges arranged in specific patterns to breach doors, walls, or fortifications. The methods are more sophisticated now, with precisely manufactured charges and reliable electrical detonation systems, but the underlying concept remains the same as what Canadian engineers improvised in Normandy using PIAT warheads and communications wire. The soldiers who developed and used the technique rarely spoke about it after the war. For them, it was just another improvisation, another example of making do with available materials to solve tactical problems. William Morrison, the Regina engineer who'd first experimented with multiple warhead assemblies, returned to construction work in Saskatchewan and never mentioned his wartime innovations to his family. Donald MacLeod, who'd earned the military medal for his bunker assault near Carpiquet, went back to Cape Breton and worked as a fisherman, deflecting questions about his war service with vague answers about engineering work. The multi-warhead PIAT assembly never achieved the recognition or fame of other combat innovations from World War II. It wasn't as dramatic as radar or as revolutionary as the atomic bomb. It didn't change the fundamental nature of warfare the way tanks or aircraft did. It was simply a practical solution to a specific tactical problem developed by soldiers who needed a way to destroy bunkers without getting killed in frontal assaults. But for the Canadian infantry who benefited from the technique, for the soldiers who didn't have to assault intact bunkers because engineers had blown them apart first, the multi-warhead PIAT assembly was as important as any high-tech weapon. It saved lives. It allowed advances to continue when they otherwise would have stalled. It gave Canadian forces a tactical advantage against German fortifications that artillery couldn't effectively engage. The technique also exemplified a particular Canadian approach to warfare that emphasized practical problem-solving over doctrinal purity. Canadian forces in World War II were often under-equipped compared to their American or British counterparts, receiving hand-me-down weapons and making do with whatever supplies were available. This scarcity bred creativity. Canadian soldiers became adept at improvisation, at finding unconventional uses for conventional equipment, at solving tactical problems with whatever materials they could scrounge. The PIAT itself was a perfect example of this dynamic. It was a mediocre anti-tank weapon that soldiers hated, but Canadian engineers discovered it could be repurposed into an effective bunker-busting tool. Rather than complaining about the inadequacy of their equipment, they found a way to make it useful for a completely different purpose than intended. This kind of adaptive thinking wasn't unique to Canadians, of course. All armies in all wars have soldiers who improvise solutions to battlefield problems. But Canadian forces in World War II developed a particular reputation for this kind of practical innovation, partly because they often had to make do with less than their allies, partly because the citizen-soldier nature of the Canadian Army meant units included men with diverse civilian skills who could apply that knowledge to military problems. The multi-warhead PIAT assembly represented the intersection of several factors that made it possible. Engineers with construction and demolitions, experience who understood blast dynamics, an inadequate anti-tank weapon that was plentiful and expendable, German fortifications that required more explosive force than conventional charges provided, and commanders willing to let their engineers experiment with unconventional solutions rather than insisting on by-the-book methods. The technique worked because it addressed a real tactical need and because the soldiers who developed it understood the underlying physics well enough to make it effective. It wasn't random improvisation or desperate luck. It was practical engineering applied to a combat problem, tested and refined through actual use until it became a reliable method for destroying fortifications. In the end, the multi-warhead PIAT assembly is remembered, when it's remembered at all, as a footnote in the history of World War II combat engineering. But for the men who used it and the men whose lives it saved, it was something more significant. It was proof that soldiers facing impossible problems could find solutions if they were willing to think creatively and take risks. It was evidence that the most effective weapons sometimes aren't the ones in the manual, but the ones you build yourself from whatever materials are available. 12 PIAT warheads, wired together in a circle, positioned 30 yards from a German bunker, detonated simultaneously to create an explosion that could shatter reinforced concrete. It looked absurd. It violated official doctrine. It was dangerous to assemble and dangerous to use. But it worked, and that was all that mattered to the Canadian engineers and infantry who relied on it to break through German defenses from Normandy to the Rhine. The technique died with the PIAT itself when the weapon was retired from service after the war. Modern armies use purpose-built breaching charges and shaped explosives that are safer and more effective than improvised assemblies of anti-tank warheads. But the principle endures in military engineering. When you face a problem that existing tools can't solve, sometimes you have to build your own solution from whatever you have available, test it under fire, and hope it works well enough to keep your friends alive. That was the real innovation behind the multi-warhead PIAT assembly. Not the specific technique, which was eventually replaced by better methods, but the mindset that created it. The willingness to look at a hated, inadequate weapon and see not just its intended purpose, but its potential for something completely different. The courage to experiment with dangerous explosives under combat conditions. The practical engineering skill to turn a theory into a working system, and the determination to keep refining and improving the technique until it became reliable enough to trust with lives. Canadian engineers in World War II wired together dozens of PIAT warheads into improvised supercharges that demolished German bunkers across France, Belgium, and the Netherlands. They did it without official approval, without proper equipment, often under fire, and always at great personal risk. They did it because the alternative was watching infantry die in frontal assaults against fortifications that conventional weapons couldn't destroy. The multi-warhead PIAT assembly won't appear in most histories of World War II. It's too obscure, too improvised, too unofficial to rate mention alongside the major weapons and innovations that shaped the war. But it mattered to the soldiers who used it and the soldiers who benefited from it. It was one more example of practical innovation solving tactical problems, one more case of soldiers refusing to accept that a problem was unsolvable just because the solution wasn't in the manual. 12 PIATs wired together, 24 pounds of converging shaped charges, one massive explosion, and a German bunker reduced to rubble, clearing the way for another advance, by soldiers who understood that sometimes the best weapon is the one you build yourself from whatever materials are at hand.